All right, here we go. Function, folks, review day 0. Well, this is for unit 0. Day 0 is okay. It was a big unit, chapters 1 and 2 in our textbook. A bunch of the stuff in this unit 0 was review of grade 11 and earlier. The definition of a function, domain and range, finding the inverse, basic graphs and transformations, and connecting graphs and situations. This idea of, describe the situation with a graph. All that stuff was review of earlier grades, where there was also a bunch of new stuff, like interval notation was new, the absolute value function was new, piecewise functions was new, and I think we'll get to a piecewise function soon. The combination of functions, the sum and the difference and the product and the composition were all new ideas, and we saw those again in unit 5, the modeling unit. And then average rate of change and instantaneous rate of change we saw for the first time in unit 02. And that seems like we've always known this rate of change business, but we'll get to see some typical unit 0 examples here in a second. So some unit 0 questions. State the equation of this graph. So what's the basic shape? Well, basic graph looks like a half a sideways parabola, right? So the basic graph is y equals the square root of x, but y equals the square root of x would normally be here, right? And you don't have to goof up here. That's the normal half a sideways parabola. And if I move that, and I can see that I've moved it. I've moved it where? I've moved it right 2 and up 1. But there's also, that's not exactly right, because where this first one is, it's up 2. And then where this one is, well, there's 2, 4. This has been doubled, right? So this has actually had a vertical stretch by factor 2. And remember, we like to do our stretches and squishes first. So actually, when we were goofing around with this graph earlier, we would have stretched it first, right? All the not horizontal, vertical distances would have been doubled. But we're not interested in recreating this. We need to just come up with the function, and I think we've got it, right? Or we will have it shortly. So the vertical stretch factor 2, that's not in with the x, right? Vertical stretch is outside, affecting x values, affecting y values, not in with the x. It's been moved right 2, opposite that you'd think, right? Right 2, and then up 1. And there's the function. And then we're asked to state the inverse of this function. Well, remember the technique is to switch x and y and then solve for them. And you can do these in either order. I'm going to try and find here's the inverse. We sort of talked about when we did logarithms that this already is the inverse, sort of stated implicitly. But now if I want to figure out what the function is explicitly, I need to solve for y. So I got to undo all these things. I'm going to subtract 1 from both sides. Eventually I'm going to square stuff, but this 2's in the way, so I'm going to divide everything by 2. Now I can square both sides. And finally add 2. Now this doesn't quite look regular, right? So here the inverse is f minus 1 at x is equal to x minus 1 plus 2. We're not used to seeing this, so probably we'd write it like this so it looks more familiar, right? Those are the same things, and we can see how to get that function. Now, notice that this is a parabola, right? This is this business. It's the whole thing. But we know this graph that's the inverse is only going to be half a parabola, right? Remember the domain, were we asked for domain and range? No, we weren't here. But here, the domain of f is x is greater than or equal to 2, and the range of f is y has got to be greater than or equal to 1, right? There's the range, those values. And remember, for the inverse, these things switch, right? The inverse, these switch. So I know that this becomes the domain. X has got to be greater than or equal to 1, and then the range is y is greater than or equal to 2. This is a restriction that's going to cut this parabola in half. And we have to include that, otherwise we goof up the inverse. All right, dandy. A couple of concepts in there, inverses and also transformations. Next one, show that this function is even. And if I write it, I kind of like it like this better, because then I can think of, well, how do I show it's even? And I could do it by graphing, but that's not very precise, right? So what I need to show that f at x is equal to f at negative x. That's what I'm required to prove. And so how am I going to do that? Well, oops. I'm going to do, if I want to prove something, I'm going to do left side, right side. A left side, right side sort of thing. Left side is f at x. The right side is f at minus x. And I want to show that these two things are equal. Well, this is just this function. And this is, where I take out the x and I fill in what goes in there, which is minus x. Now, we know this is a rule here. Cos, we know, because we developed this rule during our trig unit, right? We know that this is true. But what about this? What's the absolute value of negative x equal to? Well, let's see if we can convince you of this. These two things are equal. Why? Well, remember, if we had the absolute value function, it's actually equal to these two pieces. It's equal to x if x is greater than or equal to 0, right? There's no negative sign to chop off. Or if this is a negative number, it's the opposite. Right? Now, what happens if I replace this with negative x? Well, it's going to be the very same function, isn't it? Right? They'll sort of switch places. If x is, if negative x is greater than 0, or if negative x is less than 0, these are the same function. So in fact, this is a rule. We never talked about it then, but it is true that this is equal to the absolute value of negative x is equal to the absolute value of x. And one way for us to think of, we always think of that is this is always going to be positive, and so is this always going to be positive. So they are the same thing. Therefore, left side equals right side, and y equals absolute value of x plus cos x is even. And we've proven it. Do we got one more? Yes. We've got a piecewise function and absolute value function in here. So how does this piecewise thing work? Well, remember, similar to the definition of the absolute value function, that this f at x is equal to this if these values are the case, or this other one if these values are the case. So there's certainly a cutoff spot here, isn't there? There's, and I'm going to put in some scale here. Let's see what kind of, hopefully this will be good enough scale. If x is greater than 2, so, or greater than 1 rather. So where's greater than 1? There's 1. And so the idea is, for this side of the line, this is going to be the graph. And how do we graph this? This is, I'm going to call this graph 1. If I think of it as log base 2 of x, Well, I know how to graph log base anything, right? It always goes through the intercept and then the base in 1, and then I actually could put another value on here if I wanted to. I don't really care much, but and then also a half, -1, right? This is the inverse of the inverse of the 2 to the exponent x. But how does this work? Well, we're only going to use this blue graph on this side of the line x equals 1, right? Just this part. What about this part? Now, I'm going to erase that, or I'm going to leave it off, because on this side, I'm going to draw this absolute value function, this one here. I'm going to call this 2. Because over here on this side, I need this graph right here. Well, how do I graph that? I see there's a few things going on here. I've got a horizontal squish, factor of half, and I've got to move to the left. But the problem is this isn't in nice form. I need to factor this so I can do the stretch first, right? So I can see now the original graph. This is a horizontal compression. And this is moved left 3. And I'm going to do these pieces because it's been a little while. So the original absolute value graph would look like that, right? It's goes up like this, goes up like this, but a little bit of smart board action here. Horizontal compression means all of the horizontal distances get cut in half. This vertex stays put because what's its distance from the y-axis? Well, 0, and half of 0 is still 0. But this one is 1, and it goes to here. This one's 2, and it goes to here. This one's 1 and gets cut in half. This one's 2 and gets cut in half, and so on. So this red one now, and I'm not going to draw it in because I need to do the next part. This red one would be this function, right? But now I'm going to move this one to the left 3. 1, 2, 3, and each of these points can be moved left 3. 1, 2, 3. Watch your scale. Or I could think of just moving the starting spot and then going from there. Now notice that this graph is going to keep going like this until about here, and then there's going to be a hole there because that's when the blue one then takes over. And now this is the piecewise function put together, where this part keeps on going forever. There's a hole here at some point, and this is colored in, and then the two pieces together represent f at x. Well, there you go. A couple of typical Unit 0 questions with a little bit of logs thrown in there for flavor, and some trig thrown in there for flavor. Hopefully you got something out of that video. Next up is review day 1, which is polynomial functions.